Good afternoon. Do you know how to fix a Windows computer? Reboot it? And do you know how to hack a Microsoft computer? Use Microsoft tools to do that. So my talk is Hack Microsoft using Microsoft signed binaries. I'm Pierre Alexandre. I'm Belgian, and I work in Canada for Deloitte as a senior consultant. Doing incident response and red teaming. I have 14 years experience, and I talks at several conferences internationally, and I'm a StarCraft 2 player, and I was very happy to see Blizzard here. So I asked to the guy, when will they do StarCraft 3? I did not have any response. So why did I make power memory? My first goal was to understand the Windows authentication system into the memory, really inside the memory, in the kernel. I wanted to learn PowerShell and learn memory concepts. What is power memory? Power memory is a Minesweeper solver. That's all. Thank you very much. No, that's not true. So currently, all eyes of security guys are on PowerShell. You have a lot of tools that can detect PowerShell activities now, like Carbon Black, Tanium, but also some endpoint antivirus like Symantec. As they did a very good white paper about the increased use of PowerShell in attacks and some patterns they can detect. We get some the PowerAway, which was last year the first ransomware into the memory. I did a little script that you can find on my GitHub called invoke Tartarus that does the same thing, so running into the memory and encrypted files. But I think there are more possibilities than just PowerShell with PowerShell.exe, etc. A lot of guys are working on that, like Casey Smith, which is an awesome guy, about whitelisting a lot of things. You have Armjoy from Empire Project, Ben 10, which launched NPS, which is no PowerShell, and I did some interesting thing too with msbuild.exe. You can find it on my GitHub too. So basically, you execute a reverse shell with an XML file that you had that you host on a WebDAV server, and through msbuild.exe you will launch a PowerShell into the memory, into the msbuild memory process. Sorry. So with PowerShell, that is a Microsoft tool. You don't have to use PowerShell.exe, but the DLLs if you want, and a Microsoft signed debugger. Power memory can achieve whatever you want. In the user LAN, in the kernel LAN, and also in Wonderland. So the basic concept of power memory is just to send and receive text. So power memory sends text to debugger, and it receives text from the debugger. That's it. With this concept, you can do everything you want into the Windows kernel and the user LAN. When I say text, it's bytes. So how does it work? You have power memory from one side, and WinDBG or CDB, which is a command line version of WinDBG. WinDBG is a Windows debugger from Microsoft, which is signed. Power memory will call the debugger and send a command to execute. Then it will retrieve the bytes, parses them, and send a new command with byte to write or read to execute. So you have a server somewhere and power memory. And power memory will save for, basically for retrieve some memory information. It will say, okay, by a WMI call, dump the memory at this, for this process, by example. The server will answer, okay, here's your, by example, lsas.exe dump, which contains some interesting information like passwords. And you can do for a lot of servers if you want. But yes, I said that I dropped a binary file on the file system. And you will say, okay, you touched the disk, maybe it's not very good. That's true, but I can do it also like that. So you have the server, you have file memory, you say dump it, it will dump it. And to do that, I will use userdump.exe, which is Microsoft Tools 2, and which is signed by Microsoft. And if you are interested with this kind of tools, Microsoft wrote in 2008 a very good article with a lot of tools they create, signed to, that can lead to dump process memory. So I don't dump every day, but when I dump, I did it with Microsoft tools. So Power Memory is also a userland attacker. You can get Windows password from memory, but you can also inject and execute a shellcode in a remote process. You can modify the memory of a process. I will show you with a little demo this thing with Minesweeper, by example. Power Memory is also a kernel LAN attacker. So with DCOM, direct kernel object manipulation stuff, you can do pretty much everything that you can imagine, like hide and hide a process. I made some POC, inject all privilege in a process with system in identity, because I found with a lot of empirical approach on a lot of different operating system or version of Windows that the system hash is always the same, whatever the system you are. So you can inject this identity pretty easily. You can pass the token attack, protect a process with this concept. So also because I like a lot Active Directory, it can do a lot of things about that to recon it. So it can SPN scan, which is pretty useful when you want to find, by example, all the SQL server in a domain, all the file server in the domain. I don't know which wall you want to find, but it's very useful because you have just to ask the domain controller one time, okay, show me all your SQL server. You don't have to make an nmap, very noisy thing, but just asking to the domain controller. You get GPP password of all connected forest, not just the forest when you land it, but all connected forest. You can access also server shares of all connected forest, which is very interesting because in a lot of huge company, you have some misconfiguration of your server share, and which are often configured with authenticated user right that can and they can write on this share. So you will see that, and you can draw the EAD topology. You have also some elevation of rights inside the framework. You can retrieve site.xml file password from McAfee. I did the same day I did that. I think it was Amjoy. I don't remember, but we were two to do that the same day. You can crash operating system vulnerable to some vulnerability. You can bypass USC, etc. And yes, there is a LOL thing, because on several companies in Quebec City, you have some very old software firewall which are installed on all computers, and which can lead to ask the user, okay, give me your password, I'm your firewall, you can trust me, and you will receive this information. So that's the main menu. It's the interactive menu of Power Memory, but I also did something that's bind to Empire, and you can use it non-interactively. So the thing is with Power Memory is to debug, but not really debug, but use a debugger to read and write the memory. And I don't know if you know Jeff Resnover. Jeff Resnover is the creator of PowerShell. and he said to us, okay, automate everything. So I decided to automate the debugger to hack Microsoft. And why using the Microsoft debugger? Because it's a Microsoft sign application. So to me, it's very interesting because in a company where there are a lot of defensive mechanism, often a sign application will be trusted by a security analyst and every people inside the company. So first step, when you use WinDBG, you can do some DB, which is display bytes with little endian transformation, and you will have some very interesting information like that. You can also do display words to have 2 bytes, display double words, you understand the concept. And if you do something like DU, you will display Unicode. So in a place into the memory where you have clear text, you will have like something like my email address directly in the memory. If you do that on something encrypted, you will get encrypted bytes. So it's not getting the password inside the memory. It's not just doing DU and expecting to get the password. It was true before, but not now. The first thing you have to do is to load the symbols. What is the symbols? The symbols are PDB files, when you compile something into the Microsoft world, you will generate some PDB files. And into these PDB files, you have a lot of very interesting information. And CDB or WinDBG, which is the Microsoft debugger tool, you have the way of managing these symbols automatically. So if you say, okay, show me these symbols, and you have the PDB files, you will get automatically the right address into the memory, even if it's dynamic. So if you ask the debugger to display symbols without loading the PDB, you will have some quotation mark like that. So you load the symbols, and bam, you have the correct bytes. So symbols are free. It's Microsoft publishes them. So for all version of its Microsoft tools, but also for its operating system, from very old operating system to the newest. And the symbols we will look for getting the password will be a list entry thing. The list entry is a double linked list entry, so each elements are linked together in a circular way, and it will contain all the domain, user, and password of people which is logged on the computer you will access. So the symbol for this double linked list entry is laccess list. As a key for NT5 operating system, so like 2003, by example, or XP, is this GP DOSX key and the feedback you will need. For NT6 and NT10, it's the same thing. It's H3 DS key and AES key. And you need the initialization vector. For NT6 and NT10, it was very easy because as soon as you get this key and initialization vector, it's very simple to implement an algorithm and get the password. For NT5, it was harder because DSX, it's a DS implementation of Microsoft, which is not documented. So it was harder to decrypt the password for NT5 than for NT6 and NT10. But we need to go deeper. Let's get technical. So you want password in userland memory. Microsoft documented the Digest Security Support Provider, which is one of the authentication provider of Microsoft. You have different provider, but this one is very interesting because it manages 2 things, LDAP queries and web authentication. And in a company network, web authentication is not easy to remove because it will manage SSO authentication to SharePoint, by example. You cannot just remove that. So it's used everywhere, and you will you will always get this password. Yes, there is no reason to store the password into the memory after the utilization, because the concept is to just use the hash of the password on the network. So normally Microsoft could just remove it from memory, but it didn't. I don't know why. So the concept is to steal the bytes. You want to dump LSAS process. You can do it by different mechanisms. One, dumping LSAS process, lsas.exe, locally or remotely, because you can do it remotely too by calling WMI and asking the system to dump this process. You can convert iburst file.sys to dump file. You can make the computer crashed and get the dump file and then give it to per memory, and it will give you the password. You can leverage the hypervisor. This point is pretty much the most interesting because I will show you after, but basically if you are just an operator on Hyper-V on VMware, you are like you have more right than a domain administrator in this network. And also you can, if you have kernel mode access, you can directly access LSAS process and you have no need to dump the memory, but just access to the information you need. So I say for the hypervisor, you say you are an operator in an hypervisor environment and you have less right than a domain admin? Seriously? So this thing is on Hyper-V, but it works also on VMware. You will just use an Hyper-V tools from Microsoft, which is tools wrote by Mark Rusinovich, which is LiveKD, and which will allow you to dump the memory of a virtual machine running into the Hyper-V system. So once you have this dump, you give it to per memory, and it will give you the password. And even if you have absolutely no right inside the domain or inside the virtual machine. And it works for containers too, the containers of Microsoft. When you launch a container in Microsoft World, it will launch a new LSAS process. So you have, basically you have access to all the password of the containers once you have access to the host. Can you see the password? He is over there. No? It's like trying to find well-do. But if I show you the information like that, so you have, it's a famous double link list entry, so it's just one element of the list. This green information is the next item in the list. So the address of the next item in the list. This information is a previous entry. Then you have the address, this address, the current address. LUID address is a LUID in Windows is a unique identifier that is 64-bit, 8 bytes, and which is guaranteed to be unique until the next reboot. It's totally non-interesting for getting the password. Then the username address. If you type DU on this address, you will have the username in clear text. The NetBIOS domain name address. The encrypted password. So if you do DU on that, you will have nothing, just encrypted bytes. The domain name address and the username at domain address. It's a 2008 R2 dump, so it's not the same thing exactly, and it's 64 bits. It's not the same thing on a 2003, it's 32 bits, 64 bits. It's not the same thing than on a Windows 10, etc. So with this approach, you have a lot of things to implement because it's not always the same information at the same places. Yes, so max length, min length, that help to automate the process. So now you have the password encrypted and you need the key and then the initialization vector. So to get the key, you just type the symbols that I gave you just before that. It will give you something like that. So you type the next entry and you will get some interesting information. So in red, it says size. it's an empirical approach, so I estimate it that is always, it seems to be the size. The yellow information is a tag, which is always the same, KSSM. So next entry, you will find another tag, which is MSSK, and in pink, it's the key you look for. So if you just type DB, it will make the little endian transformation, and you will be able to inject that in your decryption algorithm. And finally, it's really the harder part, you will see. So you have to type the symbols, DB, and then you get the initialization vector. So it was really the most hardest part in all the process. So I have some demo, sorry. Okay. Okay, so it's power memory, you have the menu. You want to reveal password? Yes. You can ask power memory, okay, you will find password eventually, maybe you will find password. Do you want that I try to tell you what kind of account it is? It is a backup operator, it is an administrator, it is a domain administrator, it is an enterprise administrator, something. If you say yes, it will ask to the domain controller. So if you want to just stay in this system and don't do any request outside, you will just say no. So locally, in this case, do you want to exfiltrate the information and paste bin? No. Do you want to clear the event log on this local computer? So it's not just right click and clear event logs. It's really take the event log in place, take my specific event logs that I crafted, and replace my event log with your event log with a lot of crappy event log. So you say, okay, it will, so here he will get the SAS dump, then passes all the bytes, get the password information into the memory, and you will have administrator winning with Spring 2017, and user 1 with password 3 bang, which is very good password because it's not password 1. So you can do the same thing remotely. So yes, if I ping DC1, okay, DC1, sorry, is another computer. Okay, it's DC1. So no, I want that remote, DC1, no. So it will, through SMB, it will drop the binary that will dump the SAS process, retrieve it, then I will pass the same way that in locally. And normally, yes, MSDSC is just something I crafted. It's not at all a true process. It's just because it's very close to a real process in Microsoft. So you get the password Spring 2017. So that was for name of that. Okay. So in userlearn, you can also, with this technique, inject a shellcode in a remote process and execute it without calling API. So normally when you do that, you will say, okay, I will virtual alloc something, and then I will call an API in Windows to execute the process. But my goal was to just do all the things by just sending byte and writing byte and reading bytes through a debugger. So you have to find a memory executable zone, a null padding zone in the memory of the remote process to inject your shellcode in this memory. You need the address of the null padding zone to inject your shellcode. then you will need to pass the PE executable dynamically. So the PE is running into the memory, so you need to dynamically pass it. You will find the address of the module loaded to inject, and basically and sequentially, you will find all the information that you need until the padding zone. After that, you will be able to, so you write your bytes at the good places, and then you just change your RIP, which is the register instruction pointer, and by doing that, you will tell to the operating system to execute your address zone, and you will get a nice calculator. So I have a demo for that. So in power memory, you have power process with different things. I will create a new notepad, by example. And okay, process name, shit. Okay, process name notepad.exe. So up, and you have it. If I look in Process Explorer, sorry, you will find Notepad is injected with a calculator. And I have some interesting other findings. If you want now to, okay, I will just go back to that because we have kernel stuff too. And yes, I need to present a view. And with the same technique, if you are able to get in kernel by reusing a known technique to hide process, I will do the same thing, but just by reading and writing the bytes. So the goal is to hide a process in the correct list into the kernel. So you want to do that. If you want to do that, you have to break this link, and then it's the bytes that you will write to do that, and you need to just create new links from previous and next process. And then if you just do that, you will have a nice BSOD, because the operating system now will figure it out. It will say, oh, it's not normal, I have a process structure, e-process structure, but that is not linked to anything. It's not normal, I have to crash because I'm corrupted. So you have to redo just the link of the process you hide. And remember, I just injected a calculator in Notepad. So I want to hide this process. So I will say hide notepad.exe. So Notepad is over there. It does not work. Notepad. Yes, it's. I hide just hide Notepad, not calc. Sorry. So I will hide calc also. Okay. So it's not any calc, but if you look, calc is over there. Notepad is over there. So I want to unhide. So I need the process address that I know. And calc is there. And if I Okay, Notepad is there too. Cool. Okay. So you did some user land things and kernel land things too. I made some weaponization to be able to do that in real world, and I did a pull request into Empire, but since a lot of things happened to the project Empire, with people leaving as a company, it was not integrated currently yet, but it will be normally in 2.0 version. Yes, I will pass that. It's the, I didn't correct it, but the new pull request is 503, not 298. So if you want to do the same things with an agent that you have into the memory, you have to be fishy first, or find another technique. For the target to load the Empire agent or another agent if you have another one. Through your agent, you will load per memory in the target machine memory. Drop the signed debugger, and you will make calls to the Windows API. So if some advanced endpoint detection and response tools try to find you because you call some API Windows, it won't be able to find your stuff, and then you make fun and profits, and then you go to jail. Normally. So the demo. Yeah, I don't have this demo. I just have. I can show you. But if you know Empire, you will recognize things. I think I have this. So yes, you use credential RWMCRS and just saying run here. You will have something like that. So the same thing that in interactively mode, but in a non-interactive process. Okay, mitigation. So the first thing is you cannot trust trusted tools. You have to look really at the behavior of tools, why these tools are sending some bytes to another tools. So you have to understand what they do. You have to look for dumping activities. And a very good way to do that is to look for suspended process. So if a process is very fastly put in suspended mode, it's weird. And if it's LSAS, it's absolutely abnormal, because normally it will never be put in suspended mode. Look also for suspicious bcdedit.exe, which is another Microsoft tools allowing you to make some very interesting thing to your kernel. So asking, by example, to Windows to run in kernel debugging. Don't trust the endpoint defense mechanism implicitly, and look for suspicious user tools behavior. So you have no very simple way to mitigate this kind of attacks. And because I work from Deloitte, we have some framework to be able to mitigate this kind of thing when we do compromise assessment or incident response. So basically what we will say to our clients is look first to your crown jewels and be able to detect quickly to avoid every attacks, but to contain the damage that the attacker will be able to do to your company. Because it's not something that you will avoid. You will be attacked and it will be successful, but the thing is not to say it won't be successful at all, but okay, it will be successful, but I will be able to detect it fastly and to contain the damages. So the main takeaways is the basic SIM use cases can detect already API calls. It's easy. You have just to say, okay, I saw that this process make virtual alloc calls to this process, so it's not normal, and security analysts will be able to view that. Sorry. Using a sign debugger, okay, you drop something on the disk, but it will force the blue team to look for the behavior of your attacks, not just because this tool was assigned, it's okay, I can just avoid to look for that. You can use public symbols to get memory addresses of every Microsoft tools, but also for every tools which were compiled in Microsoft world. With this technique, you can play New Zealand and kernel land and look at Empire 503 pull request, because there is also a certificate bug which I corrected. I want to see you something before the end. So I said you can manipulate memory, and if you want to play, you can do some interesting stuff with PowerShell and a debugger. So we have the Minesweeper. I never played at this game before trying to manipulate the memory, but it's pretty cool. So you can say, okay, yes, when you look into the memory, you will figure out that 24, 8 and 30 widths, it's the maximum allowed by the computer, because it's a maximum allowed into the memory, just for that. So if I try to make some different thing here, it won't work. So by example, I will put this thing. So I have a new grid. And you have several choice. So if you want to, by example, I don't like to lose, so I want to win. So the easy way to win is to remove the bombs from the game. So I want to remove so it detects 24 times 17. If I refresh the screen, oh, the bombs are not there. I win. Yeah. Oh yeah. So because I didn't. Okay, I will reset score. And yes, I win. But you can do also, you can trick the program, because you can say, okay, I want to explode the bomb and I want to win. So the bomb will be exploded. I see them, they are exploded. If I click, it won't happen, nothing will happen, and I can just play normally and win. So that's cool, because that shows that you can basically do everything with this debugger and the PowerShell executable. And that's funny, but if you do that in another software, maybe it won't be so funny for several companies. But Microsoft likes this tool because they call it a hack tool officially. They make a signature for this tool just after I tell us, hey guys, I saw that, is that normal? They say, yes, it's not a security problem. So just after saying that, they just make it an hack tool with a sign, with a signature. And on every of my computer, even on my wife's computer, there were a lot of alerts of my own tools. Thank you. That's the end of the talk.